For this special episode of Cask and Convos, we are hitting the books and heading back to the university. We'll be diving into the future with the bright young minds who are paving the way for tomorrow. We have as our guest today Neraj Galagedara, a member of the science team of the Monash Rover project. A passionate team of students designing and building the next generation of Mars and Moon Rovers. These talented individuals are representing Australia on the world stage in prestigious robotics competitions, pushing the boundaries of innovation and developing cutting-edge skills and inspiring future careers in STEM.
So Rover is a student team at Monash University. Since about 2017, we've been building Mars and Moon Rovers that go into competition and compete against other universities. We're a multidisciplinary team full of engineers and non-engineers that build these machines for fun. Last year, our team decided that our rover was going to be bright pink, and this is a initiative started out by the women on our team and supported by everyone on the wider team. Essentially, we made it bright pink to spark conversation about women in STEM. There's a saying in engineering that when things have gone right, then you haven't found the problem. Well, if you think about it, right, when you send a rover to Mars, the rockets can only carry a certain amount of payload because that's just how they work. So naturally, our competition has the same requirement. There is a weight restriction on. There's actually a weight and space, so that you have to be fit in certain dimensions, just like a real rover has to fit in certain dimensions. So incredibly important is the weight. And well, what reducing weight means is that when you reduce weight in one area, it means you can put more weight in other areas. So that means you can have more advanced systems because you can put more weight there. We essentially budget our weight the same way you budget your finances.
In a world where innovation meets conversation, welcome to Cask and Convos, where the clink of glasses harmonizes with the spark of groundbreaking ideas. I, Shabani, welcome you on behalf of Dot Infinity to the beautiful barrel room of the La Madonna Bar on Little Collins Street, Melbourne. Here we bear honest stories, insightful reflections, and transformative ideas of product leaders from the forefront of technology. Join us as they unwind and provide exclusive insights into what defines their present and how they are steering the future of tech and customer experience. All in a relaxed bar-side chat. Welcome, Neraj. Welcome to Cask and Convos. And I believe today you're presenting a fantastic team of bright young minds from Monash University, which I believe are building their 7th Nova Rover. Would you like to tell us a bit more about the rover?
Yes. Thank you for having me first. So Rover is a student team at Monash University. Since about 2017, we've been building Mars and Moon Rovers that go into competition and compete against other universities. We're a multidisciplinary team full of engineers and non-engineers that build these machines for fun.
That sounds very exciting. But what prompted you guys to enter the competitions?
At Monash, our engineers just want something to do. We're all very passionate about something, and the University Road Challenge was the first one. The competition in Utah was a very interesting challenge. It asks you to build a Mars rover that has to complete a multitude of tasks, and to an engineer, that sounds interesting. That sounds like fun. And I think we just had the right people who wanted to make a start, and then we've just been doing that since then.
Tell me a bit more about the kind of team you guys put together, because I'm sure it might require a lot of different skill sets.
Yes. So our team, it has many sub teams. So there's a science team which deals with the science tasks, an arm team which deals with the robotic arm on the rover, an autonomous team which programs the rover to drive autonomously. Obviously, there's also the software and electricals inside the rover to make it move, and then the chassis, which is the actual main building of the rover. And then obviously we have our business team and marketing team who do all the sponsorships and marketing and events as well for us, including also the outreach as well, which is an important part of our team. This requires a lot of skills to build these things. It's not a couple of people. There's quite a few people on our team that are putting their time into making this rover.
That sounds very interesting. I never thought that there would be a business and marketing team also involved in the team of engineers. Tell us a bit about that. How does that happen?
Yeah, so I mean, we're essentially self-run. So even though we have supervisors, um, ultimately all the responsibility is on the students alone, which also means we need to secure our own sponsorship to pay for our things. The university does help us a lot. They give us a facility to work in. They might help us with international travel, and they even might give us some money at the start of the year to help us work. But we put a lot of time into securing partnerships with other companies that align with us and kind of want to help us ensure our success and build the best road we can.
That sounds very exciting. And I have been hearing something around the Pink Rover project. What's that about?
Yes. So last year, our team decided that our rover was going to be bright pink. And if you look at the photos, it is a bright pink rover.
Okay.
And this is a initiative started out by the women on our team and supported by everyone on the wider team. Essentially, we made it bright pink to spark a conversation about women in STEM. We made it pink because traditionally in engineering, femininity is downplayed or discouraged, and also being a bright pink, it is a tool to spark a conversation, to start asking about diversity in STEM and encouraging people. And this is part of our program. The other part is our outreach. So we go to a lot of high schools around the year, run little STEM workshops to encourage all people to get into STEM, but especially to kind of increase the diversity in STEM fields, and also promote the femininity and the ability to kind of present your most authentic self without being ashamed of who you are.
That is such a fantastic thought. I'm very passionate about this subject, and I think this kind of thing needs to start at the schools, because unless we start at that level, there will always be that stigma attached to STEM fields, and and the movies haven't helped with all the STEM people being shown as the uncool geeks. Of course, the geeks win the war in the end, but uh, looking at the rover now, it sounds like a very complex project. I'm sure you guys must have had challenges, especially when you're looking at such a cross-functional team and so many bright minds coming together. Talk to us about the kind of challenges you had.
Yeah, so there's a saying in engineering that when things have gone right, then you haven't found the problem, because things never go right. That you're mostly just fixing mistakes most of the time. So, for example, this year in competition, we didn't really do very well because we had a lot of issues that came up at the last minute, or so essentially what happened in one of our tasks is that we loaded the rover onto the field, we got things set up, and essentially it just didn't move. And we had something similar as well with the arm as well. And sometimes you can't plan for these things. I think these incidents really highlighted what we do when things go wrong and how we acted. And I think personally that it was a great reaction. We managed to get things done despite things not working, and also the amount of work we put into debugging and fixing as well. So I don't see them as mistakes. I just see them more as learning opportunities, because I think it was a learning year for us. But if we learn from these and implement it, I think we'll probably do a lot better next year.
What would you do next year that you didn't do this year?
Yeah. So again, as an engineer and as a science student as well, I love to innovate and I love to build things. And a lot of people have the same vibe. And the issue with that is timelines and project management don't really work well with people who just want to build the best thing possible, because sometimes we have a little bit of perfectionism to us as well, and I think what we sacrificed there was testing time, and making sure things were reliable, making sure we tested things till they break and then fix those and break them again and fix them again, because we were running basically novel systems. We didn't go in with the most reliable rover, which kind of reflected in our results.
So this time you will do a lot more of testing, I guess, and also a bit better project management.
Yeah, definitely.
I can understand that sentiment, because as designer myself, we are always trying to get that perfect design, and often timelines are always compromised. So, you can never achieve that perfect state, but it's always good to keep testing and making it better.
Yeah.
Now, talking of design, how did you come up with the overall design? what made you decide it's going to look like this? Or, of course, we know it's painted pink, but apart from that, how did it all come together? The entire, entire system of.
So the current Rover is our sixth iteration. So we've had six iterations of Rovers to kind of work on. Initially, they were a lot more blocky and a bit, I guess, heavier as well. We've managed to go from a block to more of a sheet metal design, which allows it to be light. We've improved our machining skills, so we have a lot more pocketing, weight saving, as well as we've kind of used more complex machinery. As our university has given us more access, we now have like mills, lathes, and CNCs, which has given us a lot of skills and a lot of ability to manufacture very high precision parts as well. In terms of the design, partially they're inspired by the actual Moon and Mars rovers, and then we've basically modified them to better fit our competition rules and our I guess requirements.
Mm-hmm. And talking about the Moon and the Mars rovers, I know a lot of attention goes into the wheels specifically. I think I remember reading that the Curiosity rover it could actually detach its own wheels and things like that. So did you guys go through all those kind of thinking when you were designing, say the wheels or any other parts of the rover?
Yeah, our wheels aren't as complex as that. But I will say our wheels and our wheel hubs. One of the unique things about our rover, which gives it advantage over most teams, is that we have a pivot system which allows the wheels to essentially pivot, which means the rover can move on a dime essentially, and move sideways, straight, and move forward as well. And in terms of the wheel design, we actually use two different wheels for the Australian competition, which is a lunar simulant. It is a soft wheels. They're made of TPU because the terrain is soft and it's like basically sand. And then for the Mars one, it's a hard PLA one, which we made both the wheels in house as well.
And when you talk of the terrain, that's interesting that you're looking at two different terrains. What are the other factors? When you look at Mars terrain or Moon terrain, and how do you really test for those kind of terrains? Because you can't actually really launch it out into the outer space to test your rover.
Oh, we'd be great if we could. If anyone wants to donate a spaceship to us, we'll definitely take it. But in terms of like how we test for these terrains, so Mars is a very rocky, hard environment. It's kind of clay even. So the actual competition is in Utah in Hanksville, where the Mars Research Center is, which is very close to the Martian terrain. But also we can't go to Utah every day because we're here in Melbourne. So when we're here in Australia, we like to test in basically in forests and in parks, some hard ground. We obviously can't; it's not perfect, but I think that's the best we can do. For the Moon, Moon is actually very soft. The dust is actually very fine. It's basically like a sand pit. So that's why we go to the beach and test it out, which is nice because then after we're done, we can go have a swim.
Yeah, I love that idea. Work and pleasure combined. But I also remember you telling me that you guys manufactured your own dirt.
Yeah. So so I'm on the science team, and we have to do a lot of testing. But we can't use actual real samples to test it. So for the Martian terrain, we had the exact composition of the dirt used in competition, and we basically tried to make that as best we could. We basically cooked the dirt in an oven to sterilize it, and then made our own samples. Some with some with live checked, some with water in it, and basically ran it through our systems to see what results we got.
That sounds very interesting. Actually, I wanted to ask you about you had mentioned the robotic arm.
Yes.
Tell us a bit more about that. That must have been quite complex to build.
Yeah. Someone a lot smarter than me built that. My background isn't in robotics, but they essentially it's a 60-degree of freedom arm. It's got little joints and stuff that make around with an end effector, with kind of like these soft jaws which allow it to grip onto things and move things around. That along with our pivot wheels allow us to get quite a good level of control because some of the tasks involve like pressing buttons or putting USBs into a hole, which are very fine motor controls, which are pretty hard to do on a machine, especially when you're not next to it. But yeah, the arm was actually built by our founder. He was still around when the latest arm was built. We're kind of in the process of designing a new one because it's about time for it to kind of be retired. But it's an impressive machinery. if you see it in action. And I think to improve it, I think we want to kind of reduce the weight and kind of make a bit more, reduce the backlash in the joints, so essentially make it more accurate. But that's all to come in the next cycle.
And is weight a big factor when you're designing all of this?
Well, if you think about it, right, when you send a rover to Mars, the rockets can only carry a certain amount of payload because it's just that's just how they work. So naturally, our competition has the same requirement. There is a weight restriction on. There's actually a weight and space, so that you can't. You have to be fit in certain dimensions, just like a real rover has to fit in certain dimensions. So incredibly important is the weight. And well, what reducing weight means is that when you reduce weight in one area, it means you can put more weight in other areas. So that means you can have more advanced systems because you can put more weight there. It's essentially, we essentially budget our weight the same way you budget your finances. We have a spreadsheet for the weight. Yeah.
That is very interesting. And tell us a bit about the materials, because I'm sure the materials would be contributing to the weight as well. What type of materials do you use for the construction?
So mainly in this current iteration, the rover is mainly aluminium with a lot of 3D printed parts. So that might be TPU or PLA. Kind of spread around because 3D printing is just so easy to make small parts and very intricate parts. Moving into the future, we'll probably still be using aluminium, but we are trying to use more composite parts, because composites such as carbon fiber, because they essentially have the same strength as Ali, but being a lot lighter. The only issue with that is when carbon fiber parts essentially fatigue and break, they break very differently to metal parts. So when you are fatiguing a metal part, it will start to bend, or you'll see signs of stress on it, and that's when you know, oh, it's time to replace that part or use it. Let's take that one to competition. For carbon fiber, the way it works is they have essentially micro cracks on the inside which you cannot see, and when it breaks, it essentially just snaps. There's no warning; it just breaks, which is very dangerous for competition because you don't know what's going to happen. Though with proper procedure and testing and also upskilling, we can make that work. We're just taking it slow because we don't want to risk that.
This is sounding very fascinating, and so fascinating that I'm actually forgetting that we've got our drinks waiting. I wouldn't want to deprive you of this. Well, cheers. Talking of materials and the parts, I remember when we were talking earlier, you had mentioned something around the gears. Would you like to elaborate on that?
So we're in the process of upgrading our gearboxes. We currently use planetary gearboxes, which are essentially have a motor connects into them. There's like a central gear, which we call the sun gear, and then the planetary gear is on the outside, which basically allows for a gear reduction and increases the torque on the wheels. We're moving to a cyclodal design. Essentially, this will allow a more robust gearbox. It should last us longer, have a bigger shelf life than the planetary ones. Additionally, it should be a bit more accurate with backlash, and also a bit more compact as well. So we're currently in the final stages of building our first prototype, and that should show some upgrades in our next rover.
And does it give you a lot more control as well over the overall functioning of the rover?
The control is more on like the electronic side, because essentially it's a connection motor. But I guess with the reduced backlash, there will be kind of a bit more. There won't be as much like swaying, which is good and more precise.
Great. Well, that kind of answers all my questions about the functioning and all my curiosity about the rover. But I was curious to know, as students of Monash, this sounds like such a fantastic opportunity. But curious to know from your perspective, what were some of the learnings that you had?
Yeah. So obviously, like I've learned a lot of technical skills. I've been given the opportunity to, which is one of the great things about Monash, engineering Monash, is that the student teams allow you to really test out a lot of things and learn. But I think one of the great things about Nova is that the environment that we're working in. Firstly, you're surrounded by amazing students, not just engineers, but just amazing students who are all passionate about this, who are volunteering crazy hours a week into building this thing for free. they've also, the environment that we work in is such that it is quite, you're quite free to make the mistakes. You're actually asked to really make as many mistakes as you can and try and fix them. And there's no judgment, because I think overall, even though it might be your project, you are it's a team effort. And it's great that they've promoted that. And also I've learned is things such as testing and reliability, how important that is. Also learning how important it is to essentially how to prototype and how to use it. Basically, use essentially, like a lot of people try and build a really elaborate prototype. I think it's part of perfectionism as well.
Yes.
But using basically like MacGyvering up some duct tape and some string and some tape, making a prototype like out of a bottle or whatever, to just test the proof of concept like that. That's a skill that I think we don't really get taught. We don't realize how important it is until you're actually in a design cycle where things aren't really working. You need things to work.
Yeah, I'm sure that is one thing which is important, and something that you will actually take for your future as well, because given in the kind of field that we all are coming from, prototyping is such an important aspect of it, and you guys are doing it live. So did you have any funny moments when you guys were prototyping things? Did you realize while prototyping that, oh my god, this really did not work the way we were planning to, because of the fact that you prototyped it?
Oh, I mean, I think we were designing a cache system that was basically capturing the funny part was the initial prototype was some guy was just he wasn't even in Melbourne at the time. He was just like away, but he wanted to still help out. But he got a Coke bottle and he built it, just made some cuts into it and built it, and he showed a proof of concept, essentially pushing it into the dirt and how it would actually work as a viable prototype. We didn't end up going with that design because I think there was issues with it. Many trying to make it for real. But that's kind of a funny example. It's not really a mistake. I think most of the mistakes are like, for example, when you're machining something and you kind of forget to put a part somewhere, or you're not centered anymore. You're like, oh, you're slightly off tolerance, which means you have to throw the whole thing away and start again, which gets frustrating. But I think it's part of the fun of it.
Yeah, absolutely. And I must say, given in Cask and Convos, most of the times we tend to get people with a lot of professional experience.
Yeah.
And this is the first time we are having a student, and I love the energy and the fresh perspective that you have brought to our conversation. And if I'm not wrong, you guys are also going to bring your rover to the Festival of AI and Robotics. Is that right?
Yeah, that's correct. We're having head of the fair. We'll be there essentially we'll have a booth there on both days. Awesome. You can come down and say hi. Otherwise, we are also doing a live demonstration of our rover. You're going to see in action. We'll explain some of the cool, intricate parts that we've built ourselves and designed ourselves, and also answer any questions anyone has and how we actually done it.
Awesome. I'm sure a lot of people will be very interested. I know especially my husband and my son are definitely going to not miss that. They both are space geeks. Lovely. So I'm definitely going to take them along and looking forward to that. So thank you so much.
My pleasure.
For coming in today. I've loved having this chat with you and getting your fresh perspective, and hopefully we'll get to meet the rest of your team as well during the festival.
Look forward to it.
Thanks, Neraj.
Thanks.
From data management and product innovation to regulatory compliance, whether it's optimizing costs or enhancing efficiencies, Dot Infinity is your partner for solving tricky problems with a human-centric and tech-powered approach. Connect with us at contact@dotinfinity.co.